Okay, this is going to be a quick little video to remind you the trigonometry process in general, um, and talk about the three types of trig problems we're going to encounter. I have three examples here, one to represent each type. Now, we don't actually know which type we're going to be using until we're at step 3. So I'll write which type is which when we get to step 3. I know, because I wrote these problems, but for you, practicing this new skill might not be super obvious straight away, and you might not realize until step 3 which scenario we're looking at. All right, so step 1, quick run through of all of the steps of the process. First, you're going to assign sides as opposite, adjacent, hypotenuse relative to whichever trig function you're going to use. Remind us the definitions. Sine of acute angle theta is the opposite side divided by the hypotenuse side. Cosine of acute angle theta is the adjacent side divided by the hypotenuse side. And tangent of acute angle theta is opposite side divided by adjacent side. Okay, so opposite, adjacent, hypotenuse. The hypotenuse is always the easiest. It's always across from the right angle. So in problem number 1, a quick overview of sine sides. Figure out what you know, what you're trying to solve for, and that's when you're going to identify which one of these three to use. So step 2 is identify the trig function. Step 3, you're going to substitute the info from the problem. 2 known pieces of info, 1 unknown piece. And that's when we're going to figure out which scenario that we have for algebra, which is step 4. Step 5, pick up the calculator. And step 6, check your answer at the end. There is 2 main calculator issues we may encounter, and at the very end of the video, I'll talk to the people who may have calculator issues. If you enter exactly as you see it and get this, then you're good. You don't have calculator issues. All right, first things first. A sip of coffee. And now assign sides. So the hypotenuse side is always opposite the right angle. The side that is opposite the acute angle we're going to use is opposite. And adjacent is the side that touches the acute angle. The step 2 now is to take a look at what I know and what I'm trying to solve for. So I'll solve for AC first. So I'm looking for this side, and I know this side, and I know this angle. So you know 2 things, and 1 thing you don't know. And it looks like opposite and hypotenuse, that is sine. So step 2, we take a look at what we know, what we don't know, what we're trying to solve, and figure out, well, which one of the trig functions are we going to use? And now we realize it's going to be sine. We'll just write that definition down. Now step 3, once we figure out which trig function to use, we're going to substitute these 3 bits of information into the problem. 2 of them are going to be numbers, acute angle theta, and 1 of the side lengths, and 1 is going to be an object. I'll call this AC, the side that we're missing. So sine of 65 degrees, theta is always just an acute angle, equals the opposite side, which is AC, over the hypotenuse side, which is 17. meters. And this is going to be the first of our 3 algebra scenarios when the variable is in the numerator. This is the easiest of the 3 versions because it's a one-step, one and done. To get rid of your fraction, you're just going to multiply both sides of the equation by 17. Because when you multiply a fraction by the denominator times 17 divided by 17, those two cancel out. So we get AC is equal to 17 times the sine of 65 degrees. A quick reminder, a number in front of a trig function is like a coefficient. Means multiply. And the number after the trig function is some acute angle. Most of you, hopefully, will be able to pick up your calculator at this point and just enter it exactly as you see, 17 sine 65, and hopefully get 15.407. So this is AC. We'll just write 15.4. That's in meters for our final answer. Okay, I'm going to show you actually a trick here, a calculator trick. We have 2 of the 3 sides of the right triangle. We have the hypotenuse, and we just figured out that the opposite side is 15.407. We want to use at least 3 decimals, or even better, leave it in your calculator screen. And we can just Pythagorize in the calculator. So here's one of my legs. I'll square that side. Okay, I'm going to subtract 17 squared. Now, this is a negative number, so I'm going to multiply this by -1 to get the positive number, and then take the square root of that. So that's the Pythagorean theorem that I got 7.1845, yada, yada, yada. So that's 7.2 rounded to 1 decimal place. Now, we could have used trig again. For example, BC is adjacent, and I know the hypotenuse. Zoom out a little bit here. So BC is adjacent, and I know hypotenuse, so I could have, a different step 2, used cosine theta is adjacent over hypotenuse, leading me to a different step 3. Cosine of 65 degrees equals adjacent BC over hypotenuse 17. And then it's still the same scenario, variable in numerator, variable up top, to just multiply both sides by 17. And I left that in my calculator to show that 17 cosine 65 is the exact same number you get if you use the Pythagorean theorem. So you have 2 options. You really only need trig once per problem. All right. The last step, when you know everything from a triangle, and when you know 2 of the 3 sides, you can use the Pythagorean theorem, or you can use trig twice. You should know that this final angle here is going to add up to 180 with 90 and 65, so you can figure that's 25 degrees just using the triangle sum theorem. The final step is a quick little check. I'm putting all my final answers into my little triangle, and the final step is a check. When you know all of the side lengths and all of the angles, you can double check that the longest side is opposite the largest angle and the shortest side is opposite the smallest angle. If you do correct work and just put it in the wrong spot, you'll violate that, so that's a little check at the end. Okay. All right, so most of the steps of this process are pretty much exactly the same, so I'm going to go a little bit faster through the rest of this. The only difference really is in step 4, the algebra. So steps 1 through 3 are exactly the same. I'm going to use 32 degrees. So this 26, that is the side opposite 32 degrees. It's across the triangle from that acute angle. TG here is the hypotenuse because it's across from the right angle. And the side that touches the acute angle along with the hypotenuse is always the adjacent side. All right, I think I'm going to solve for TG first. So in step 2, I'm looking for the hypotenuse. I know the opposite and I know theta. So the trig function that uses hypotenuse and opposite is cosine. Sine uses hypotenuse and opposite. I tricked myself there for a second. It's definitely sine. So opposite hypotenuse, sine. So we write down that definition. Sine theta equals opposite over hypotenuse. That's step 2. Step 3, we're going to substitute the numbers from the problem. Sine 32 degrees equals the opposite side, 26 meters, over the hypotenuse side, TG. And now we have 2 steps of algebra to get TG by itself. The first step is just like what we did before, multiply both sides by the denominator to get rid of the fraction. And we're going to do that here as well. We're going to multiply both sides of this equation by TG. On the right side, we get rid of the fraction. And on the left side, we just have TG times the sine of 32 degrees. And then to get TG all by itself, now we're going to divide both sides by the sine of 32 degrees. And this is exactly the expression for TG. 26 divided by sine 32 degrees. And I get 49.1 is how that would be rounded to 1 decimal place. Because you want to look to the next decimal. Because the next decimal is 6, we round this decimal place up. So 49.1, that's a side length. That is the hypotenuse. The other missing side, or the other leg, is 26. So we can just Pythagorean straight away. We'll square that hypotenuse. We'll subtract the square of the leg. We'll take the square root of what we have left over, and 41.6 is side AG. Okay, this problem is in meters. And then lastly, if this angle is 32 degrees, angle T here must be 58 degrees because the three angles add together to be 180. So last, with a quick little check, we got a 41.6 meters here, 49.1 meters there, and 58 degrees here. Let's just double check. The longest side, 49.1, that's opposite the right angle, excellent. The shortest side, 26 meters, that is opposite the smallest angle, 32 degrees. Excellent. All right, just looking at the time on this video, I think I'm going to have calculator issues as a separate video. And if you enter it normally, you don't even have to watch that video. If you are getting other answers when you try to enter this on paper, then all of the paperwork, this process is fine for you, but you're going to have to watch the other video for your step 5, picking up your calculator, entering in your calculator. So if you are entering what I have here on paper and you're getting wildly different answers, watch that calculator issues video. I forgot to label number 2. The scenario is variable in the denominator. All right, the third algebra type is when we don't know one of the angles. So we have to just pick one. So this is a little bit of a different step 1, but not wildly different. I'll just pick angle A. It doesn't really matter which one we choose. And for the sides, this is 2 root 10 is the side that is opposite the right angle, so that's the hypotenuse. 2 meters is the side that's opposite the angle A, and this is the side that touches angle A along with the hypotenuse, so that's the adjacent. I'm going to do a quick little Pythagorean theorem to get what AC is. So 2 root 10, this reminds me of a process here. Just make sure we know what we're doing. When you square 2 root 10, it's 2 times root 10 times another 2 times another root 10. So the 2 times the 2 is the 4. Root 10 times root 10 is 10. 10 times 4 is 40. Subtract the 4 from both sides. Take the square root of both sides. All right, so we can actually use the 10 root 2 as a side length, but now we just found a nice whole number, so let's use that instead. All right, so now 2 of the things that I know are side lengths. I actually know all 3 sides, and the unknown is A. So we know all 3 sides. We could use any trig function, but I think it'd be easiest if we use these nice whole numbers. So opposite, adjacent, 2 sides that we know. The angle is the side we don't know. Which trig function uses opposite and adjacent? Tangent. So we write down the trig function. In general, tangent of theta is opposite over adjacent. So when we substitute we're going to substitute the A as our theta. That's the unknown, angle A. And then the opposite side is 2. Adjacent side is 6. And this is the situation. Variable is the acute angle. I just realized I spelled variable wrong here. Variable. So important. Variable is acute angle. Okay, and this is when we're going to compose both sides with the inverse trig function. Trig functions are not multiplication. They're a function itself, and the way that we cancel it out is with inverse trig. Inverse tangent of A, cancel each other out, and we just get A. Tangent inverse of 2/6. These parentheses are super important. My calculator opens parentheses up for me when I hit second tangent. Second tangent gets you the inverse tangent on most calculators. And then we have 2 divided by 6 in parentheses. And that gives us our angle, 18.4 degrees. Okay, we can calculate the complement of that, which is the other acute angle, just by subtracting 90. And last, a quick little check. I got this to be 18.4 degrees and this to be 71.6 degrees. Quick little double check. The longest side, well, what is 2 root 10? It's got to be the longest side, 6.3. So the longest side is opposite the largest angle, and the shortest side, 2, is opposite the smallest angle. All right. Hopefully that cleared up any issues if you were having them.